Good evening. My name is Namrita. I am pursuing BE in Electronics and Communication at Saidri College of Engineering and Management, Mangalore. And today I am very excited to present my learning experience from the Emertxe Embedded System internship. During this internship, we explored the architecture of PIC16F8 7XA microcontroller, worked with its peripherals and implemented various functionalities using embedded C. The aim was not just to understand this microcontroller programming, but also it helped to apply this knowledge in designing embedded projects effectively. Okay, let's move further and go in detail what all the things the Emertxe team has trained us in terms of doing a project. Team Emertxe trained us deeply initially in C programming, exploring its power, efficiency, flexibility, and system level depth. C is widely used in system software, embedded system, OS kernel development, firmware, middleware, and drivers. We also know that C is a general purpose language with free formatting. It is highly efficient and portable. C relies on libraries to enhance its functionality. Okay, in 2 days of three, I think it's a 3 days of C training. It includes many things. It includes data type, keywords like int, char, float, double. And we also learned about conditional statement and looping statements such as if else, switch, for, while, break, and furthermore, uh, and also we went deep, uh, like we also went to its sizes, like the character data type carries 1 byte memory to store, and a C program consists of documentation, preprocessor directives, global declarations, the main function, program statements, and function calls. We also learned about functions, many things. We'll look at with examples, and these are the key features which I conclude on the training of C programming in C by Emertxe. And basic data types was integer, character, floating point, double. It stores whole numbers without decimals, and this and floating points it involves it stores with decimals, whole numbers with decimals, and uh, and double is also similar to the float itself, but it have double of decimal when compared to floating point. Okay, we also went through this common operators: arithmetic, addition, subtraction, multiplication operations, division, modulus, relational operators such as equal to sign, not equal to, greater than, less than, logical operators and logic or, logic not. These all statements we are going to apply in the coming project slides. Like we have applied. Okay. Um and also we learned about functions, and here it is most of the time used in this project implementation, because we have defined these functions in the main.c, and we call them in microwoven.c, and these are the syntax for the function we use. And we also use extern keyword. It declares a variable or function defined in another translation unit. Okay, and okay, we also explored char in float and double, along with modifiers like short, long, signed, unsigned, qualifiers like constant and volatile help manage data efficiently in embedded system. Conditional constructs. We learn decision making using if else, switch, and loops like for, while, and do while. The break and continuous statements help control loop execution. Throughout the internship, we implemented various C programming programs, debugging techniques, and real-time embedded applications. Here, the declaration part, how to declare the variable, and how to define the variable, and how to use the function and include it in the file. Also, we have declared here variables using external keywords. The next slide. Okay, we also learned about storage classes. Like we have used auto, static, extern, these type of keywords in this project, and these are the functions. Auto by default it makes and preserves its variable state between function calls, so restrict function visibility to the file. Extern access variables or functions define other files. Okay, header files. This is the very important files. If these are not included, we'll get errors. And we have many header files in this project, like teamer.h or matrix keypad.h and isr.c okay, that is a C file, a source file, and many header files are used here. And how to declare the library header file, and this is the example we have given here. I have included. And coming to the next one, we go on through the embedded system, and this was handled by another ma'am. And definition of embedded system is given as embedded system is any combination of hardware and software designed to perform a specific task. And we went through many examples. These are the components we have used in the embedded system. Like not we have gone through microcontroller, system on chip, um, RAM memory, RAM random access memory, read only memory, flash memory, and this is analog to the peripheral ADC and DAC, and power supply auxiliary systems like cooling mechanism, human interfaces, display, keyboard, touch screen, and what are all sensors, software, actuators. Uh, and also, I have listed the requirements and challenges in embedded system. These are the points I have noted on concluding this embedded system training. And we have also gone through many examples of embedded system: smart watches, washing machines, industrial robots, and medical devices. And we also went through many categories of embedded system: standalone, works independently, and a real time one. In real time, we went through hard real time, firm real time, soft real time, and networked. It's like examples like IoT devices and mobile, like portable systems, smartphones, tablets. Okay, and okay, common design matrices we have went through is time to prototype, speed of development, power consumption, energy efficiency, performance, and its correctness. These are all things we have learned in embedded system training. And next, we went to the block diagram of the project. What to implement exactly in the project. The explanation was like the first uh, in in the project, the first screen should be as powering on, like this is one a plan or a blueprint for the project should be implemented. What should it we implement? Okay, powering on microwave was first, and it have four options: micro mode, grill mode, convection mode, and start mode. Micro mode, like it displays power 900 watt and set time, and we should enter time using keypads. And it when we click star has asterisk, it clears. And if we enter hash this one hashtag, it enters the time, and it starts running like 3029. It goes on. And if we want to pause the time, stop the time, we use 456. Here I didn't mention, but what all things we are going to implement I'm explaining here. So, and the time, when time comes to zero, the time up, enjoy your meal gets displayed. Next, when we go to grill mode also it's same as micro mode. It grills the food and it lasts time up, enjoy a meal. And in convection mode, we can set temperature. Like first we heat the microwave oven and next the food will be cooked. Okay, next the screen will be preheating time. If we enter 200 some temperature, it heats for 1 minute. If you want to heat again, you can heat it. And in start mode, it starts from 30 seconds and it increments by 30 seconds if you click 4 keypad. Okay, let's get into the project. Here I'm going to explain a code implementation, how code is implemented, and we use simulator PicSimLab and board PicGenius and controller PIC16F877A. Okay, it includes functionalities for a character LCD interface, matrix keypad, input time, timer configurations, and various operational modes such as microwave, grill, and convection. Okay, CLCD interface. We have gone through CLCD.h and CLCD.c. The header file CLCD.h is used to uh, here its functions are defined, and the CLCD.c is where run the we call the function. Here, CLCD interface manages the communication between the microcontroller and the character LCD display. It initializes CLCD by setting up the data ports and control lines, and it also writes data or instructions to CLCD based on the mode. Place a single character at a specified address on the CLCD. Displays string starting from a specified address on the CLCD. And matrix keypad handles input from a 4 into 3 matrix keypad, allowing user interaction with the microwave oven. It configures the row pins as outputs and column pins as inputs, enabling keypad scanning. It scans the keypad and returns a key pressed. The mode parameter determines whether the function returns immediately or waits for a key press. Here, timer configuration sets up timer 2 to generate periodic interrupts, which are essential for the time-dependent operations like cooking, duration, and preheating one. Okay, we went through many predefined one, and also we used microwave and main.c to write code, and these CLCD matrix keypad was given by Emertxe. File was downloaded using the Emertxe Moodle app, and in main we have initialization in operation of microwave oven by integrating all modules, calls initialization function for CLCD, keypad, timer, configures input output pins for fan and buzzer control. And we also use interrupt service routine, that is ISR.c, handles timer 2 interrupts to manage time independent features like countdown timers for cooking and preheating. And operational flow of the, as I already said, this micro oven, upon powering on, the power on screen function displays welcome message and menu navigation. The user navigates through the menu using the keypad to select cooking modes or start the cooking process. Setting parameters depending on the selected mode, the user sets the cooking time, set time or temperature, set temperature, cooking process. Once parameters are set, the heat food function starts the cooking process. The time display keeps the user informed of the remaining time. The interrupt function, ISR function, ensures that time-dependent operations are accurately managed through timer 2 interrupts. This internship has been an enriching experience, and here are my key learnings. Okay, and these are the key files which we have included in our projects, and I have given the overview of this things, and I want to show you what I have did in my which which I have did with the help of ma'am. And here we cannot explain everything, but some function. Okay, we have initialized CLCD, initialized matrix keypad, and to run this to include run the fan, we have included fan is equal to 0 at initial stage, and also initialized timer 2. And here we have used the while statement, key read matrix key mat first if operation equal to menu screen key equal to 1. Here, when one is pressed first, it clears screen, otherwise it will overlap each other. And operation flag micro mode start mode is equal to 0. First, it displays the statement 900 watt, and with the delay, clear screen and resets the mode. Reset mode function is defined reset mode. Here we have defined this, and we have defined all the things, and buzzer is connected to TC1 and RC1. This was given in the data sheet, which we have learned. And these are the matrix keypad header library. We have defined here everything high, low, high is equal to 1. If we use high, it is easily can be accessed by the system. And here we have used many functions, power on screen, and we defined in the micro and dot h. And here we have what all the things should be done. We have displayed a second screen as 1, 2, 3, 4 micro grill convection modes. And next the when star is hash is pressed, what all the functions, what all how should it works, it is executed in this part of the code. Fan will be on when entered. We have entered hash. Okay, next this is done for preheating one. The function will be done in main.c heatful. And I want to show the demo of my project. I'll restart this. Um, okay. Okay. I'll open Fixing Lab. Something got shown. Okay. I'll set it to 20, 16. Okay. Micro powering on. This screen is on, and now it displays four options. And when I click to one, power equal to 900 watt, and can set time. I'll set it for 10 seconds and enter. And I can also pause by clicking 5, and next I can start by clicking on 4 and time up. Next it jumps to grill mode, sorry, the menu screen. Next I'll click to 2 and enter time of 20 seconds. It's enough. And I can also clear this, and here 20 seconds, enter. And I can also stop directly by pressing 6. 3. Next is convection. Convection, we can set temperature for 212. When I enter, it heats for 1 minute. This is preheating one. Okay, why is this not running? Okay, preheats. and time is 30 seconds. You are facing the problem in simulator. It suddenly gets stopped. So, okay, 12 seconds remaining. 10. Okay, we can also enter extra time. Oh, like enter, transfer. I can also stop it. Okay, next fourth option is 4. When press on 4, it starts from 30 seconds. And if I click 4, it increment by 30 seconds. If I click 4, increment by 30 seconds. Okay. Can pause this. Okay, next I can start. Resume. Okay, stop this. Okay, these things I have implemented, and thank you, because I feel happy I have ended this internship successfully. I gained a stronger foundation in C programming and embedded C. To conclude, this internship has provided me with hands-on experience in embedded system, depended my programming skills, and prepared me for real-world system design challenges. I look forward to applying this knowledge in future projects. I look forward to applying this knowledge in future projects and advancing in the embedded system domain. Thank you. And thank you for this opportunity. And Emertxe have trained us a lot about embedded C and microcontroller PIX 16F877A. Thanks a lot. I'm concluding this presentation. Thank you.